In this video, we're going to take a look at how to create this part in SOLIDWORKS. This part is part of a design competition held every year at SOLIDWORKS World called Model Mania. This particular part was the model that users had to create in SOLIDWORKS World 2000. If you're not familiar with Model Mania, the goal is to take a drawing similar to this one and create the part as quickly and as accurately as you can inside of SOLIDWORKS. Now the real challenge is you'll be given a second drawing when you're finished with this, and you'll also have to make a design change adhering again to time and accuracy. We're going to show one of the many infinite ways that you could create this part inside of SOLIDWORKS. So let's go ahead and take a look at the drawing before we get started and see kind of what we're going to be focusing on. Looking at sections AA and BB, we can see that there's this predominant dome feature as well as that the part's hollowed out. There's also a ledge that kind of revolves around this part. Then if we take a look at the front and top view, you can see there's this extrusion that comes out of the front. If we go look at section CC, we can see that all the information we need is there. Going back to the top view, you can see that this feature is also copied or rotated 45 degrees out to the right. And finally, there's a cylindrical feature that's also rotated at a unique compound angle, 45 degrees to the left, but also looking at section BB, it's at a unique angle up off of 6 degrees as well. So let's go into SOLIDWORKS and see how we'll get started. I'm going to go ahead and start by creating a part. Now this drawing was provided in Imperial English units. If you look down here at my unit switcher, you can see that I'm using millimeters, grams, and seconds. I'm going to choose inches, pounds, and seconds just so that I'm using the right unit. Now I'm going to start by creating a revolve feature on the front plane. To do this, there's a few things you can do to make life a little bit easier. You can start by creating a center line if you know you're going to be creating a revolve feature. This will come in handy in a little while when we actually generate the feature. Now I want to draw the profile and I want to completely enclose it. So I'm going to start with the line tool and I'm going to come straight up along this center line, and I want to create the arc that comes out to the side. Now you'll notice I'm still in the line tool, but in SOLIDWORKS if you drag your cursor back to the beginning, you'll notice you can pull an arc straight out off from it, or if you go directly out to the side you can create a perpendicular arc as well. So I'm going to go ahead and snap that out here to the side to make sure it's straight across, and then draw a line straight down to the bottom and then bring it around. Now one of the things, if you remember the drawing, it's also going to be hollow. Well, we can capture that material thickness information here as well using offset entities. Now when I initially select this arc, you can see that it's going to try to offset the entire profile. That's not what we needed. We actually only needed this arc and the line below it. So let's go over to the property manager. Let's start by changing the offset to 0.25, and then here you'll see that we can first of all flip the direction to go to the inside, which is what I want to do in this case. But there's also this option that you could unselect that's enabled by default called Select Chain. Now if we go back to the sketch, all we need to do is select that second entity, right click, and press OK. While we're here, let's go ahead and capture that rectangular feature as well that kind of comes out. I know the height is 0.25, so I'm going to enter that right now, but I don't know what the thickness of this is. In fact, the numbers on the drawing are given to us in a diameter format. So let's look at how we'll do that now. If you wanted to dimension this, for example, you could go from the outside to here, but that's only going to give you the radius value. In SOLIDWORKS, if you dimension from an entity to a center line, remember I mentioned the center line is going to give us a lot of valuable capabilities. If you move your cursor across that center line, you'll notice that the dimension changes to be the diameter value. And in this case, I know the diameter to be 2.7 inches. This way I don't have to do any math to calculate what the radius is. We can then again just simply select this other line, and SOLIDWORKS remembers that we were creating diameter dimensions, and we can enter 3.75. The last value that we want to define is going to be the height. I'm going to select the top of this and the bottom of this, and we'll place this dimension, which is 3.35 inches. Now in this case you can see it's not fully defined because it looks like I didn't quite draw this arc to be tangent. If I select this point right here, I can just make that tangent quick and easy. We also need to define the location of this, which is 0.25 inches off from the bottom of the part. So let's place that dimension as well, and there we go. All the geometry is black, which lets us know that it's fully defined. Now it's time to go ahead and revolve this. When I choose the revolve feature, you'll notice SOLIDWORKS doesn't initially give me a preview. That's because I have multiple closed and overlapping profiles. Instead, SOLIDWORKS is going to automatically put us into selected contours mode. Now, you'll notice selected contours is really useful. You can pick just particular areas or certain pieces of geometry in your sketch to include. And in this case, I want to choose this outside profile. Now, when I do that, I likewise don't get a preview. And the reason is SOLIDWORKS by default did choose thin feature because of all the profiles. If we deselect this option, you can see the preview now appears, letting us know what we're going to get. I'm going to go ahead and choose this rectangle while we're here as well, and then right-click to confirm. And there we have the initial feature. The next thing I want to work on is going to be that extrusion coming out of the front. If you look at the drawing, you can see section CC really provides all the information that we're looking for in this case. So if we go back to our model, an easy way to do this is to just start creating this from the front plane. I'm going to go ahead and start drawing this by creating, again, a center line. Now you'll notice I'm snapping to directly over my origin, and if I draw that line straight down, it's black, meaning it can't move off from the center. This is going to give us a good anchor point for all those circles. And you'll see why I created a center line here in just a minute. I'm going to snap to the midpoint and the endpoints. And you can see that no matter how I adjust this, those two outside circles will always be the same distance. Now, one of the other things I want to do here is I want to ensure that these two circles are always the same size. So using the Control key and selecting them, I'm going to choose equals. Now, let's just go ahead and add a few dimensions. Well, one more relationship actually. This arc also needs to be tangent to the top of this dome. So again, using the Control key, I'll select them both and choose tangency. Now, when I go to place this dimension, you'll notice SOLIDWORKS by default is asking me to enter a diameter, though on the drawing it's given to us in radius. That's okay. Go ahead and just simply place the dimension, and while still in the dimension tool, you can simply right-click and choose Display as Radius. Now I can double-click on it and enter the 0.38 inches that's provided on the drawing. Let's go ahead and do that again for this circle. So again, it's going to ask for the diameter. I don't know what the diameter is. I could do the math, but I'm going to go ahead and just press OK, choose Display as Radius, and now I can type in 0.61. Looks like I was actually about right on the money there with that number. And then the last thing we want to do is dimension the distance between centers, which is 1.75 inches. The last piece of this is going to be those tangent lines between these arcs. I'm going to go ahead and do this. You'll notice in SOLIDWORKS, if you draw off from a circle in a tangent motion, SOLIDWORKS automatically captures that for you. This makes it really easy to go ahead and then all I need to do is find the proper tangent location on this arc. It looks like I'm having a little bit of trouble finding it here. There it goes. You notice it, the little icon next to my cursor lets me know that it's found it. Let's do that again. I'm going to come straight off, and I'm going to snap to tangency there. Now I don't want to do that again. I want to simplify my work. So I'm just going to use my Control key and select both of these lines, the center line, and then grab my Mirror Entities tool. And SOLIDWORKS will automatically understand that you want to mirror the solid geometry across the construction line. So with that done, let's go ahead and choose to extrude this. I'm going to choose extrusion, and again, SOLIDWORKS, you'll notice next to my cursor is giving me that funny little icon. That's asking me to use selected contours because all this geometry overlaps. You could trim this up and SOLIDWORKS would know what to do, but I want to really show that you can use selected contours to make this process easier. Let's drag this out. Let's get it to the right value here, 2.75. I'm going to snap to that. And we've got our three circles, but we also need these inner areas. So I'm just going to select those regions, and you'll notice that SOLIDWORKS adds that to the geometry. So there you have that. Now there's another few features we might want to add here. There's a hole that goes through this part, and as well as two drilled holes that are going to go on here as well. For the main through hole, I'm going to go ahead and just draw this on the front plane, and I'm going to look at this normal too. I'm going to hover over the arc to find the center here, and then I'll just enter the diameter, which is 0.75 inches. And then let's go ahead and choose a cut extrude. It's going in the wrong direction, so let's drag it out. But you don't want this just to be blind. What if the length of this changes? We're going to change that to through all and confirm. We'll do the same thing with these holes that go on the front of this face. well, not quite the same. These aren't going to be through all. But I am going to snap to the center, and I'm going to type in this diameter of 0.38. And for the second hole, you'll notice I'm just going to go ahead and draw the circle. The reason I'm doing that is so I can use my control key to select both of these arcs and add an equal relationship. The reason I did that is so I only have to ever change this one dimension to change both holes. Now let's go ahead and just choose to cut those into that part. We'll just type in a value of 1 and press OK. Now, here's where things get a little interesting. If we go back to the drawing, we can see that all of that geometry we just created is copied 45 degrees to the right. So if we come back to our model, we can do this using a circular pattern. I'm going to go to my pull down, choose circular pattern, and let's go ahead and select those features. I'm going to grab this extrusion, this hole, and these holes. Now, we haven't gotten a preview, and that's because SOLIDWORKS requires something to pattern about. This could be an axis, a piece of reference geometry, a temporary axis, or a circular face or edge. I'm going to just go ahead and select this circular face. Now, the preview shows us it's going in the wrong direction, so let's go ahead and reverse that and make sure the dimension is right at 45 degrees and press enter. So there we have that. We've got our cuts kind of going through our part. We might run into a problem, it looks like, later on. I'm going to show you how to fix that. The last thing we want to do here is if we go back to the drawing, we have this cylindrical boss that comes out at this unique compound angle. So we could do this one of several ways. I'm going to do it using some construction geometry. I'm going to start by creating a reference plane. Now, a reference plane can be created you can select a variety of pieces of geometry. I want to find the center of my part. SOLIDWORKS actually provides you with something called temporary axes on every cylindrical part and feature you create. I'm going to choose the center line of our whole part file here. That's all I need it for, so I'm going to just toggle those back off for clarity. Then I'm going to go ahead and choose the right plane to dimension about. Now you can see by default it's selected perpendicular. We can change this to use an angle, and there we go. We can go ahead. It's at the right angle. It looks like it's coming to the outside, but you'll notice that when I create it, I can just drag this plane out like so. So what I want to do now is I want to go ahead and create a sketch on this plane. And I want to not look at it from the front because that might get a little complicated. So let's go to the back. But you'll also notice it's tilted 90 degrees to the side. If you hold your Alt key and press your arrow keys, you can rotate about increments directly what you're looking at to really make that easier. Now, to build this second angle that we're going to work with here, I'm going to start with a construction line. I'm going to go ahead and I'm going to just draw this out randomly, and you'll see why in a moment. I know that this needs to fall on the center of this part. Now, I could turn those center lines back on, or I could hold the control key and grab the origin and just make sure that these are vertical to one another. Not vertical, horizontal. And I also want to define this angle. So we know that that's 6 degrees. Now, the last thing we want to do is draw the actual geometry itself. And in this case, I'm going to go ahead and I'm going to use a 3-point rectangle. This is a nice way to just draw a rectangle out and draw it out like so. So we have a few dimensions that we know here. The first is the diameter. We're going to use that same trick we used before where we dimension to the outside. And then we're going to go ahead and grab the center line, and when we cross it, we can enter that diameter value of 1.2 inches. Now the location of this is a little unique. It's dimensioned to the center off from the bottom, which is 2.35. So let's go ahead and grab that geometry, 2.35, and then it's also dimensioned from the center. So we're going to go ahead and dimension from here to here, and that value is going to be 2.4. So there we go. We've got it fully defined. All that's left for us to do is go ahead and choose to revolve that. We also do want to create the cut that goes to the inside, but I want to take a look at the inside of this part right now. If you remember back to the very beginning, one of the things that we did is we thought ahead and we included that geometry in this first sketch. Well, in SOLIDWORKS, you can reuse a sketch as many times as you want by simply selecting it. This time, I'm going to go ahead and do a Revolve Cut instead, and again, SOLIDWORKS is going to ask for a selected contour. I'm going to choose that inner region, and you can see from the preview at the bottom what we're going to get. When I press OK, you can see that SOLIDWORKS creates that cut for us. Now, we may have run into a few problems, and that's because of the order we created these features. These extrusions went past this hole. Now, I could fix this a few ways. I could make sure that the hole happens after this pattern and then create an additional pattern, but another easy way to do this is just to select these faces, right click and choose from the faces pull down. If it's not visible, hit the double down chevrons and choose delete. I'm going to use delete and patch and simply just remove those, and SOLIDWORKS will take care of that for us. The other thing we need to do here is we need to create a hole on this face. I'm going to go ahead and again snap to the center, and the diameter of this hole is 0.82, and I'm going to go ahead and choose to cut this into the part. Now be careful, because choosing through all like we've used before will actually go through the entire part. In this case, we actually want to choose the up to next option in this case, and here you can see we get exactly what we're looking for. Now, the last thing we need is a handful of fillets. And if you go back to the drawing, we can see in the lower left, it just says all rounds are to be 0.188 radius. So if we come back, let's go ahead and add that. I'm going to start by grabbing my fillet tool. We'll type in the radius value that we want. And I'm going to go ahead and grab my first edge. Now you'll notice SOLIDWORKS gives me the ability to select similar geometry. And you can hover over these and see if you find exactly what you're looking for. Sometimes you will, sometimes you won't. The first one's pretty good here, but let's go ahead and just grab this dome and this edge. You know what? Let's clear this selection. Let's start by grabbing the dome and seeing what SOLIDWORKS grabs on that face. This makes it a little bit easier just to fill in the blanks. We'll grab that edge, and we want this edge down here, and there we go. So we have our finished part. We've gotten that done. Now is where the interesting part happens. We get section 2 of the drawing. On phase 2 of the drawing, you'll notice that there's a few changes that are taking place. Only those dimensions that are changing have been highlighted to make things easy for us. Now this is a really simple case because this goes back to SOLIDWORKS 2000. As we get into later Model Manias, these get even trickier. So let's look at how we have to solve these. It's not to say that these changes are going to be perfect. The first one is this diameter right here. Now, if I pull these dimensions off that I've created, you'll notice the first value we're changing is this 2.7 to 3.4 inches. And when I do that and I go ahead and click update, look at that. We do have some problems in our design. But let's go ahead, let's take a look at the rest of the changes first. The next change is the overall height is changing. In this case, this is going to change to 4.5. So we'll go ahead and do that. And the height here is going to change to 3.5. So we'll change that. And so we have a few problems. Well, one of the problems no longer exists, this delete face. If we take a look at it, notice the extrusions no longer interfere with that hole. So all we have to do in this case is delete the delete face. That's not really needed anymore. The fillets are a little bit more unique. Let's go ahead and take a look at what's happened here. Some of the edges don't quite blend together the way that they needed to before. And there's an edge missing here. So I'm going to start by removing that. And we're going to go ahead, we're going to pick some of these edges and see if we can just get this to solve on its own here. Not making any promises that it will. Okay, it looks like that's not going to solve our problem for us here. So we might have to tackle this with a little bit of a unique solution. Let's start by clearing selections and seeing what we can get. I can get this one. I can get this one. And I can't get that second one. So maybe the way that we're going to have to tackle this is to create this as two separate fillets. So let's go ahead and just add another one. An easy way to do this is just to select it and press Control C. We'll grab this edge and press Control V. And you can see SOLIDWORKS then takes care of that for us. Sometimes a fillet just needs to be created in two features to get the right results. So there you have it. This is one model from Model Mania 2000. You'll notice you can also download the part reviewer part here to see how this part was created inside of SOLIDWORKS. Hopefully you enjoyed, and stay tuned to next week when we look at Model Mania 2001.